We add another 4. 12 plus 4 is equal to 16. So, do you have any questions? Okay, no one has question. Let's proceed to the next one. So number 23. How many sides are there in the polygon below? Okay, number 23. This polygon has 4 sides. 1, 2, 3, 4. Okay? The answer is 4. And the other one is also 4. 1, 2, 3, 4. Okay, very good. Let's proceed to number 24. So, number 24. How many squares is or are there in the figure below? Okay, we're going to count. First, we're going to count the 1 by 1 square. So, a square like this. So, this is 1. So, 1 by 1 square. So, that is 1. This is 2, 3, 4, 5, 6, 7, 8, 9, 10. So, 10. However, there are still big squares that we can see. So, square like this. So, this is a 2 by 2 square. So this is also a square since their sides are equal. So 2 by 2, there is only 1. And lastly, the biggest square we can see, this square. So the big square is also 1. So there are no more squares. So we're going to add 10, 1, and 1. So 10 plus 1 plus 1 is equal to 12. So the answer is 12 squares. Okay, someone wants to ask about question number 21. Okay, let's go back to question number 21. Okay, for number 21, if problems are like this, there's going to be a multiple choice. So, example, there are possible choices. 5 rather. So, to answer this one, the children will just choose from the question. Okay? For the one asking for number 21. So, for special questions like this, the children is going to choose. Regarding that one, actually I am just a lecturer, but in the real test, there is going to be a proctor. So don't worry, they are going to provide instructions. So the proctor are the one who's going to provide instructions. So don't worry about it. So let's proceed to the work that we left. So the last problem that we solved is number 24. Okay, so children, let's have another 10-minute break. Since we're already number 24 and we still have a lot of time, so 10-minute break. Let's be back by 5:06.
A $2 coin or coins can he exchange these coins for? Okay, so the first thing that we're going to do is we're going to solve how many money does Jackson have. Since Jackson have 10 $5 coins, we're going to multiply 5 by 10. So 10 times 5 is 10 plus 10 plus 10 plus 10 plus 10, which is equal to 50. So if you multiply like this also, 5 times 0 is 0, and 5 times 1 is equal to 5. So we know that Jackson has $50. So the next thing we have to do is we need to exchange this with $2 coins. So we're going to divide 50 by 2. So to get 50 by 2, that is 25. Also, one way that we can solve this is we're going to find a number that if we're going to multiply by 2, we will get a result of 50. So since 25 times 2 is equal to 50, it means that Jackson can have 25 $2 coins. Okay, did everyone get this problem? Okay, very good. So let's proceed to number 26. How many different ways is or are there to express 9 as the sum of two one-digit numbers? So, we need to consider 4 plus 5 and 5 plus 4 as 1. Okay, so we need to add numbers. So, let's start with number 1. What do we add by 1 to get a result of 9? Please don't spam in the message. So what do we add in 1 to get 9? The answer is 8. Okay? So that is one way. So the next thing that we're going to do is let's do with number 2. What do we add by 2 to get a result of 9? So what do we add to 2 to get 9? 7. Okay, the answer is 7. Next, we're going to type 3. So what do we add to 3 to get 9? So the answer is 6. And lastly, what do we add in 4 to get 5, to get 9? The answer is 5. Okay, correct. The answer is 5. After that, next to 4 is 5. Since we know that we need to add 5 to get 9, and it is shown that in the instruction that is counted as 1, so we're going to stop in 4. So the next thing that we're going to do is we're going to count how many ways. So this is one way, this is second way, this is a third way, and fourth way. Which means we have 4 ways. So the correct answer is 4. So did everyone get it right? Okay, very good. Let's proceed to number 27. Among the values of the following expressions, who has questions? You can chat in the box if you have questions. So we are not going to count 0 plus 9 since this is 1-digit number, so 0 is not counted. Let's proceed to the next one. Let's proceed to number 26. Among the values of the following expressions, how many 2-digit number or numbers is or are there? So let's try this first one. 3 plus 5 is equal to, what is 3 plus 5? Anyone knows? Okay, the correct answer is 8. So next is 15 minus 7. What is the answer? Okay, 8 again. What is 22 minus 5? So 22 minus 5. 12 minus 5 is 7. So the answer is 17. Okay, correct. What is 59 minus 24? Okay, correct. The answer is 5. What is 13 minus 5? Okay, correct. 8. The answer is 8. Next, what is 23 minus 9? So 23 minus 9. So we borrowed 1. 13 minus 9 is 4. 1 minus 0 is 1. So 14. Finally, what is 1 plus 9? 10. Okay, very good. Now, the problem is that we're going to find how many two-digit numbers are there. So, 8 is only one digit, so that is wrong. Next, 8 is also one digit, so that is wrong. Then 17 is two digits, since this is 1 and 7, so this is correct. 5 is one digit, so this is wrong. 8 is also one digit, so this is wrong. And 14 is two digits, so this is correct. And finally, 10 is two digit, so this is correct. So we're going to count. How many do we have in all? So 1, 2, 3. So the answer is 3. Everyone get it correct? So again, we're going to count how many two-digit numbers are there. It is 17, 14, and 10. So a total of 3 numbers. Okay? So 1, 2, 3. So let's proceed to number 28. So which number below is the smallest? So you have 20230210. We have 20211305. Next is 20230002. And finally 2022-809. So what we're going to do is we're going to arrange them like this. So first, we're going to compare the first two digits. So this is 20, this is 20, and this is 20, so it is equal. So next is we're going to compare the next three digits. So this is 230, another 20. So 230, 221, 230, and 229. So among these three numbers, what is the smallest number? So the smallest is 221, which means if this is the smallest, then the smallest number among the four is this one. So the answer is 20,221,305. Okay? Did everyone get it correct? Let's proceed to number 29. So number 29. So number 29, Peter has one $1 coin, two $2 coin, and three $5 coins. How many different values of products can he buy without any changes? So the first thing that we're going to do is Peter has one $1 coin, so that means he has $3. Two $2 coin, so that means he has $2, so that is $4. Next is three $5 coins, so that is $15. So how many different values of products can he buy without any changes? So 5 times 3 is 15. 2 times 2 is 4 plus 1 times 1. This is 1. So we're going to solve. 1 plus 4 plus 15 is equal to 20. So the answer is 20. Okay, did we get it? Okay, let's proceed to the next question. So this is our last question. So choose 4 digits without repetition from 1, 3, 5, 7, and 9 to form 2-digit numbers. What is the maximum possible value of the sum between the two numbers? So first, what we're going to do is we're going to choose 4 numbers. So among the numbers, we're going to choose the largest number. So the largest numbers are 9, 7, 5, and 3. Next, we're going to get the two largest number. So that will be our first digit for our two numbers. Next is we're going to pair the third largest to our first largest. So since 5 is the third largest, we're going to pair it with 9. We're going to put 5 here. And the last largest, we're going to pair with our second largest, which is 3. After that, we're going to add 95 and 73. So 5 plus 3 is 8. And 9 plus 7 is 16. So our correct answer is 168. Do you have questions? Okay, everyone got it correct. So let's get back to the problem that everyone was confused. This one, okay? Let's try to count again. Let's start with this one. So we have 1, 2. And this is 2. And this one, there is 1 connected. For this one, there's only 1 since we already count it being connected here. So this is another 1. For this dot, there is 1, 2, 3. We put 3. And lastly, this dot has 1. So we're going to add 1 plus 2 plus 1 plus 1 2 1 1 plus 3. And this one is also connected here. Okay? So plus 1. So the correct answer is 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 3 is 8 plus 1 is equal to 9. So this one is a straight line. Okay? So any questions? Okay, very good. Everyone got it correct. So we have already finished all our questions. So any more additional questions before we end our discussion? Any final questions? So someone asked about number 23. Okay, let's get back to number 23. Number 26. So what we're going to do here is we're going to start with 1 paired by 8 to get 9. 2 paired with 7 to get 9. 3 paired with 6 to get 9. The next is 4 paired with 5 to get 9. So if we continue with 5, it's going to be paired by 4. So it's repeating. Same with 6, 7, and 8. So we're only going to consider this one. So the answer is 4. And next is number 23. Someone asked about number 23. So number 23, the answer here is 8. So this question is a bit confusing because there are 2 polygons. But the answer here is 4 for this one and 4 for this one. So the answer is 8. So any more questions? 0 plus 9 is not counted because we go back to number 26. one-digit numbers, so 0 is not counted. Based on the answer key, 0 is not counted. So we're only considering 1. So that's all. We're going to end our discussions now. Let's try number 29. Okay, number 29. What is the question, bro? So we're going to multiply 5 times 3, then 2 times 2, and 1 times 1. So this is 15 plus 4 plus 1 is equal to 20. Okay, so the question is how many products? So example, for I think this one might be confusing. But based on the answer key, this is the answer. Okay, so that's all. Is there any more questions? I think we're going to end now.